Okay, so let's jump right into this. We're going to explore a really fascinating idea in AI today. The idea that sometimes, to make an AI smarter, you actually have to teach it less. It sounds kind of weird, I know, but we're about to see exactly why a whole team of focused AIs can run circles around a single, overworked genius. I mean, it goes against everything you'd think, right? More data, more training, that's supposed to make a better AI. But what if I told you there's a tipping point? A moment where you try to cram one more piece of information into an AI's brain, and the whole thing actually starts to perform worse. So let's figure out why that happens. The entire problem really comes down to this one key idea: class overlap. Just imagine you're teaching an AI to tell the difference between a few things that are super similar, like different kinds of engine noise. Well, the AI starts to get confused. The part of its digital brain that's supposed to handle one category starts to bleed into the space for another. It just gets messy. And the result is exactly what you'd expect. It starts making mistakes. Its accuracy just tanks. It's kind of like you trying to follow three different conversations at once. You're going to mix things up. This confusion zone is the absolute enemy of a high-performing AI. So what's the fix? Well, this is where the whole strategy flips on its head. Instead of using one generalist model and forcing it to learn everything and get all confused, we build a team of specialists. Each AI on the team gets one and only one job. It's a really elegant solution that just completely sidesteps that whole confusion zone problem. Okay, so how do you actually go about training one of these highly focused specialist AIs? Well, it's actually surprisingly simple. The whole key is to give each one an incredibly clear black and white mission. The game plan is just crystal clear. For Model A, its entire world boils down to one simple question. Is this thing I'm looking at label A, or is it not? That is it. Same thing for Model B with label B, and Model C with label C. There's no gray area, no maybe, and absolutely no overlap. And this table here, it shows you exactly how we turn each model into an expert. Take Model A. Its job is to find label A. So we show it 146 examples that are label A. But, and this is just as important, we show it 380 examples of everything else, all the things that are not label A. This or not this training is what makes it so incredibly sharp at its one job. And that right there is the magic of this whole approach. Each specialist model gets to build its own independent little brain, totally separate from the others. Remember that class overlap problem we talked about? It's just gone. It's been eliminated by design. But we can actually take this a step further. So what if, for any single task, we didn't just have one specialist on the job? What if we built a whole super team of different kinds of specialists, all focused on the exact same goal, and had them work together? Let's check out how that makes the system even more powerful. This is what's called an ensemble approach. So to find label A, we don't just ask our one specialist. Nope. We train 3 completely different types of AI models on that exact same task, and then we make them vote. If 2 or even all 3 of them agree on the answer, well, we can be a lot more confident that it's the right one. And here's the lineup for our super team. We're not using clones here, we're using 3 totally different kinds of experts. First up, you've got EfficientNet, which uses something called a CNN. It's really fast and amazing at spotting patterns in images. Then you have the Vision Transformer, which is like the heavyweight that's great at seeing the big picture in tons of data. And finally, the Swin Transformer, an advanced model that can see both the tiny details and the big picture at the same time. Each one brings a totally unique skill to the table. It's this diversity that's so powerful. It creates this built-in system of checks and balances. See, where one model might have a bit of a blind spot, another one sees things perfectly clearly. This kind of collaboration just dramatically boosts not only the accuracy, but the overall reliability of the final answer. You can just trust it more. Okay, so we've got our super team of specialists all assembled. But there's one more critical piece to this whole puzzle. What are we actually feeding them? Because it turns out the type of data you give them can make a massive difference. So the researchers, they tested 2 different data diets. The first was full data, basically giving the AI everything, a whole 5x5 grid of information. The other was power data, a much smaller 5x2 grid that had only the most important bits of info. And you might think more is better, but get this. The focused power data actually led to better results. It turns out that for an AI specialist, just like a human one, Cutting out the noise is the fastest way to get to the right answer.
All right, so after looking at all of this, the specialist models, the super teams, the optimized data, what's the big takeaway here? Why does any of this matter for people who are actually building and using AI in the real world?
It really all comes down to four pretty powerful lessons. First, specialization beats generalization. An expert is almost always going to outperform a jack of all trades. Second, a team is better than one genius, especially when every person on that team has a super clear job. Third, diversity is a superpower. Different ways of looking at a problem lead to stronger answers. And fourth, and this is a big one, what you put in determines what you get out. Giving your AI the right data is just as important as the AI model itself. And this quote it absolutely nails it. The future of really powerful AI might not be about building one giant all-knowing superbrain. Instead, the real breakthrough comes from creating these smaller, focused, independent learning spaces that let experts get to a level of accuracy that a single, distracted AI could just never dream of matching.
And that kind of leaves us with one last big idea to chew on. This concept of a team of specialists is obviously a game changer for AI, but where else does it pop up? Think about medicine or engineering or even big creative projects. Where else can we solve these seemingly impossible problems, not with a single lone genius, but with a carefully chosen team of focused experts? It's something to think about.